Hello, hello. And today we're going to wish a belated happy birthday to Stu, aka the pedaling pianist. And we're going to try, as far as I can tell, the only puzzle of his on Logic Masters Germany that does not have a rating. And so hopefully we can get this rated. If you're watching this and you solve the puzzle, like you go try it yourself, please do me a favor and head over to the Logic Masters Germany link in the description and input the code and tell Stu how much you liked his puzzle. So this is called Double the Grids, Double the Solutions. It's got a lot of rules, so the rule box is kind of small. And I omitted one rule because there's actually two versions of this puzzle. And as far as I can tell, the only difference in these puzzles happens in this cell right here, where one of them is odd and the other one's even. Otherwise, the puzzles are exactly the same. And he says one is easier and one is harder. We're going to try the easier one. If it's too easy, maybe we'll try the odd one or the even one. I can't remember which is which now. We'll try the harder one, and we'll see how that goes. But only if we get through this in reasonable time. So let's go through some rules. So we've got two 4x4 sudokus. So in each of these are separate puzzles essentially. I mean, not separate puzzles, separate grids, each of which have 5 digits from the set 0 to 9. So this one's obviously going to have a 5 in it, but otherwise I could choose any of the 5 digits from 0 to 9, and those are the 5 digits that are going to go in these 4 cells. I think there's S, yeah, and then there's S cells. Oh, and sorry, one more rule is there are no digits in common between the two grids. So if I know the 5 cells here, for example, I'll know the 5 cells here are the opposite. Okay. Then S cells. So the reason there's 5 in each grid is because there's Schrodinger cells, which means that cell contains 2 digits. And so every row, every column, and every box is going to have one Schrodinger cell that has 2 digits in it. And the value of a Schrodinger cell is the sum of the digits in it, and no two Schrodinger cells in the entire puzzle. So in all 8 of these, no two can have the same value. So that's a different type of restriction than normal. Mad mods. Values on a length n line, so I assume that's all these lines, must be different. So the values must be different on the lines. Okay, so I can have the same values, even with a Schrodinger cell. So this can be like a 3 and a 1, 2, for example. They must have different values, but the same remainder when divided by n. Okay, so n is 4. So these could be, for example, 0, 4, 8, and 12 with a Schrodinger cell or something like that. But they all have to have the same remainder mod 4. So it could be 0, 4, 8, 12, 1, 5, 9, 13, 2, 6, 10, 14, right, etc. Okay. Different colors are just used to disambiguate crossing lines. Yep, that makes sense. Disjoint grids. 2 cells in the same position in each grid, so that's these, for example, may not have the same value. Okay, so I think that only matters for S cells, because if it's not an S cell, they're just going to be different because they can't be the same digits. So the S cells can't match. They can't match another S cell anywhere in the grid, and they can't match a value, in a particular spot, whatever that means. The given 5 is not an S cell. And then the rule that I cut off here because it's different in 2 puzzles is this cell is odd. And that is it. Those are the rules. So, okay. Let's start here because as I was talking about this, I realized that there's really only 2 choices here, which is this could be 0, 4, 8 with 12 or 16, or 1, 5, 9 with 13 or 17. Because if I try to do something else, so one of these could be a Schrodinger cell, but the rest can't be. So I need at least 3 digits that are 9 or less. And so on a mod 4 line, the only way to do that is 0, 4, 8 or 1, 5, 9. If I try to go to 2, 6, 10, I'm at 10, and that's too much. So, and now I'm seeing actually it's the same exact thing going this way. So actually this is going to be our Schrodinger cell. Oh, maybe that's not true actually. Let me think about that for a second. Let's just think here. One of these is going to be a Schrodinger cell. And if it's, oh, and it's odd, right? So this is the odd puzzle. So this is odd, which means the Schrodinger cell, which I think will be here, but I don't know that for sure yet. The Schrodinger cell is going to be either 13 or 17, and the other ones are 1, 5, 9. Because this can't be 0, 4, 8, because then these would all be even. Because this is a mod 4 line, right? If one is even, they're all even. If one is odd, they're all odd. So these are all odd. These are all odd. And so the digits that are not on Schrodinger cells are 1, 5, 9. And then, oh, and then it can't be 17, right? Because 17 would require 8, 9, but 1, 5, and 9 will be taken. So it can't be 8, 9. The Schrodinger cell is going to be 13, which can't be 4, 9, because 9 is taken. It can't be 5, 8, because 5, 8 is taken. It can be 6, 7. And since that's the only choice, and now I am sure that this is a Schrodinger cell, because if I tried to put Schrodinger cells, say, like this, they would both have to be 13, which would violate the rule that no two Schrodinger cells can have the same value. So these are not Schrodinger cells because they see a Schrodinger cell. And this is 6, 7, and the rest are 1, 5, and 9, and of course these are not 5. Okay, and now this is a mod 3 line. And I know the digits are 1, 5, 9, 6, and 7. So let's think about how that could work. I could have 9. So the way I'm thinking about it is, for each of these digits, what do I need to put up here? So if this is 9, I would need a non-Schrodinger cell, because one of these cells is not Schrodinger. So if this is 9, I need a non-Schrodinger cell that has the same mod 3 value as 9, which is going to be 6. And then the 7 is going to have to be up here somewhere in a Schrodinger cell with 5. So that works. I could have 9, 6 by itself, and 5, 7. I guess it'd have to be up here. 5, 7 up here. So that's one way it could work. If this is 5, then I need something else I need 2 or 8, which is not in this puzzle. So this can't be 5. If it's 1, I can have 7 in here, and then I need 2 digits that add up to a 1 mod 3 number, and I need a 6 up there in that cell. So it would have to be 6, and does that not work either? 6, 5 is 11. I mean, 6 would have to go with another, yeah, 6 isn't going to work because I need another, so I have 1, 7, and I basically need 6 for to make that work, because 6 is 0 mod 3, so I would need another 1 mod 3 number to make that work, because 6 would, in fact 6 and 7, I mean I can just say 6 and 7 have to go up here somewhere. So if this is 1, I need a 7 by itself, or basically I need 2 digits that also have 1 that are 1 mod 3, which I can't have. So this is actually a 9, and these are not. And then what did I say? With 9, I needed a 6 somewhere by itself and 5, 7. So this is 5, 7, and this is 6. This is not Schrodinger. These are not. And we knew before that that's not Schrodinger. So this is, I guess we knew that anyway. So I've got the Schrodinger cells placed. I have 12 and 13 as values. This is not 5 either. So this is, this is 1, 9, 5. Okay. So far this is seeming like it definitely, this can't be 6, 7 pairs. This is 6 or 7, and this is 1 with either 6 or 7. I'm going to put a 1 in the corner mark to say that's definitely there. And this sum is either 7 or 8, none of which seem contradicted yet. So this is also going to be 6 or 7. It has to be 6 because of this 5, 7, so that's 6. This is in fact 1, 7, that's 6. I can just finish this now probably, right? I need a 7 in here, and it can't go with 1 because I already have an 8. So this is 7, 9, making this, whoops. It doesn't circle around. These are all possible cells. And then what's this? This is 1. Okay, halfway done. Okay, this is 13. So these are all 1 mod 3. Okay, what are the digits in this? These are 0, 2, 3, 4, and 8. And at least one of these is not an S cell. and it has to be 1 mod 3, and the only one like that I think is 4. So one of these is a 4, and the other one is an S cell. So these are not S cells. One is a 4 that's not an S cell, and one is an S cell with 2 digits that add up to 1 mod 3, which could be, and it can't have a 4 in it. So, and that's the only one, so it's not going to have 3 in it, or 0. So it's going to be 2, 8. Yeah, okay, so one of these is 4, and one of these is 2, 8. And then I got rid of these I shouldn't have. I think these are 0 and 3. That's all the digits, right? Yeah, these are 0 and 3. But do that right? Seems too easy. But I think that's the only thing that works. Let's think about these. I have 3 digits, at least 2 of which have to not be S cells. So at least 2 of these have to have the same modularity mod 3. I could have 2 and 8, which are both 2 or 0 and 3. So if I have 2 and 8, the other one would have to be, I can't get to 2 mod 3 with what's left. So it can't be 2 and 8. It's got to be 0 and 3. And then it's got to be 4 with either 2 or 8. And can I get rid of one of them? So 12 is already used, so I can't use 4, 8. So these are, and that's true both ways. So this is going to be my 4, 8, no, 4, 2 Schrodinger cell. And these are not going to be Schrodinger cells. And these are all 0, 3. And that means the digit that's left over is, wait, hold on, 8. Did I forget a cell? So this is now not the 2, 8. This is the 4 non-Schrodinger. This is the 2, 8 Schrodinger. So this is not, this is not, whoops. And this is Schrodinger. Can I disambiguate these with these Schrodinger cells? No. So what, let's just keep trying. So this is 0, maybe I should use some A, B's or something, but let's just, what digit has to go here? 2. So there's definitely a 2 here with either 0 or 3. Are 5 or 2 taken? I don't think so. So that makes this 4. This is 8. This is 4. Oh, this is also 2, is it? Hold on. 5. These can't be the same digit. So this is 0. Which means this is 3, 0, 3, 0. Yeah, 5. Okay. I think it's right. Let's try it. Not yet finished. Oh, sorry. 0, 3. Let's try that. Yeah, all right. Cool. Neat. I was expecting this to be much harder based on the fact that not many people have solved it. So let's try the other one. And let's see if it's how meaningfully different that makes the puzzle. Because the only difference is that this is now even. By the way, I think the solution check is for this puzzle. So if you did this puzzle, the easier version, I think you can go do the solution check. So go rate it. Okay, so this is the same thing, right? Let me just make sure this only can be one thing. So 3 of these digits are 0, 4, or 8, and I have 12 or 16. 16 would be 7. Oh, but I have to have a 5 in the puzzle. So it's 0, 4, 8, and 12. There's only one way to make 12 with a Schrodinger cell. I mean, there's only one way we can make the 12. It's 5, 7, and we can't repeat it, so we can't have it on both. So this is also the exact same logic is going to apply here at the opening, just with different digits. So these are now all 0, 4, 8, and this is 5, 7. And what do we do next? We did this, right? And so can I go through these and see what doesn't work? So if this is 8, these have to be, I can put a 5 on there, and then I would need 7 with 4. Okay, so I could do, if this is 8, I could do 5 with 4, 7. That's one way that could go. If this is 4, I would need 7 by itself. Actually, the 5 definitely goes here. because 5's not here, it's not here. So there's definitely a 5 here no matter what, so that's going to be helpful. So if this is 4, I would need a 7 by itself, which can't go with the 5. So this would be a 7. Oh yeah, so 7 can't go here, and 7, so 7 has to go here either way, actually, too. That's interesting. So if this is 4, I end up with 7 by itself. What pair would pair with 5? I would need, does 8 work? Yeah, 8 works. So 5 would go with 8, 7 would go with 4. If this is 0, I would need a 3, 6, or 9, which I don't have in the puzzle. So this can't be 0. I see the difference is that I think we only had one choice here before, and now we have 2. And I bet at some point we're going to run out of logic. So the 5 definitely goes here. I can't put 5 and 7 together in a Schrodinger cell. So 7 here, exact same logic is up here. But now I don't have a line to put these together. I really have no idea. I guess I can put a 7 here. But that could be a Schrodinger 7. Yeah, I don't know. But these are 0, 4, 8 at least. But could be Schrodinger. I don't know. Let's try going over here earlier. So if this is 12, these are all 0 mod 3. What are the digits? I have 1, 2, 3, 6, 9. Okay, so I have a lot. I see why this is so much harder. There's so many digits that could, and I bet. Okay, let's think about this for a second too. Again, I need 2 non-Schrodinger cells to have the same modularity, the same residue mod 3. So this has to be a 0 mod 3. And I can't do 3, 6, or 9 doubled over here. I think I can do that here. I could have, say, this could be 3 and 6, and this could be 9. But I can't do that here, because then the third cell would have to be a 1 or a 2, which doesn't work. So, but I could have, so there are kind of 2 choices here, right? I could do 3, 6, 9, like that. That's one way that could just work. Or I could have a 1, 2 Schrodinger cell somewhere, and 3, 6s, and 9s on the rest. Is there a reason? I want to put a Schrodinger cell right here. Is there a reason I have to put a Schrodinger cell, say, on this line? Like, what if this was just 3, 6, 9? Will that cause a problem? Well, this would become a Schrodinger 1, 2. Which means I could not do a Schrodinger 1, 2 again, which means this would also have to be. So if one of them is 3, 6, 9, they both are. But yeah, but then I get 1, 2 Schrodinger cells everywhere. So that does not work. That does not work. So I need a 1, 2 Schrodinger cell on this line. By the same token, I think the exact same logic is going to apply here. So this has to be a 1, 2 Schrodinger cell. And then these are going to be from 3, 6, and 9. These are all going to be from 3, 6, and 9. And then what? 1 and 2 have to be separated in these, have to be separated in these. But they're both going to have a Schrodinger cell, actually. So, but none of them conflict with this 12. So I don't know how I'm going to get purchased with that. So there's no 1, 2 Schrodinger cell on this line. So these are actually all also 3, 6, 9. But they could be they don't have to be, but they could be Schrodinger cells. 1 and 2 are separated here. Oh, interesting. I'm gonna corner mark, not 1, A, B, because 1 and 2 are separated in all of these grids. So I don't know, one of them I'm going to call A, one of them I'm going to call B. I don't know. Let's see. So what are my Schrodinger cell possibilities? I probably don't have to think of all the Schrodinger candidates simultaneously, but I might. Well, 8, 4 can't be a Schrodinger cell because we already have 12. So, okay, in this box, Schrodinger is either 11 or 13. In this box, Schrodinger is either 15, 11, 7, 5, 9, 13. There's no way. Well, if this is, so we need something, if this is Schrodinger, because we get a chain here. If this is Schrodinger, we get 11 in the Schrodinger cell. We get either 4 or 8 in a Schrodinger cell. And then 5, 9, yeah, no, that seems okay. And this one doesn't really resolve. What this one? No, those will be okay. Oh, can these both be? Hold on. If these are both Schrodinger cells, they would need different other digits. So whatever digit here would have to go here. The 048 digit would have to go here. This becomes Schrodinger cell, so it couldn't be 4. Oh no, oh yeah, sorry, these are the 48. No, sorry. If this is Schrodinger, this is Schrodinger, and this is Schrodinger. 7, 4 will be taken. These are to be 7, 0, and 7, 8 separately. This would be 4, so this would be 4. So whatever, 7 will go 0, 8 here, it would be here, it would be here, and it would be here. So it would be 8, but that works. I think it works. Okay, wrong, we're breaking up the wrong tree. What am I missing? Oh, these can't be 3. That's what I'm missing, because they can't, the mod lines have to have different values as well as the same remainder. So those can't be 3. So these are, there we go. That is what I'm missing. So that's not 3. 3 is definitely here. I recently learned that tab switches between number and letter mode. So if you're looking for a keyboard shortcut for that, that is the keyboard shortcut. This can't be a Schrodinger cell. Wait, no. No, I'm absolutely wrong. That could be a Schrodinger cell. I'm tempted to make C and D 6 and 9. Because I mean, I know that, for example, these are the same. And these are the same. Because these have to be different. And these have to be different. So these are the same. These are the same. And I'm wondering if I can get C and D all the way around this grid somehow. So D is not in here, but could, and C and, good, glad I did that. C and D are not in here, so that's just a bare 3. Which means it's not Schrodinger. And then, sorry, just getting a text. Okay. And then what? C is up here. D is here. This could be a Schrodinger cell. Do I get problems? Like if this is Schrodinger, I think I get problems. Yeah. So if any, I think this is going to have to be the Schrodinger cell, because if A is a Schrodinger cell, I get all the A cells are Schrodinger cells. I don't think I have enough other digits to pair it with. Because the 3s are all taken. So A here would have to get paired with, A is 1 or 2, remember. So A here would have to get paired with 6 or 9. Here would have to get paired with 6 or 9. Here would also have to get paired with 6 or 9. And the same exact logic would be true here. If this is Schrodinger, this is, and this is. So B would have to get paired with 6 or 9 in 3 different places. So one of them would have to repeat. So this is my Schrodinger cell. These are not. These are. And now I can just, these just are A, B, A. Wait, no. I colored it wrong. These are Schrodinger. But I do at least get these. So these are B, these are A. So this is going to be B with D. This is going to be A with C. Yeah, okay. A is 1, 2. A and B are 1 and 2. C and D are 6 and 9. So my possible My possible pairings here are 8 and 10 or 7 and 11. Is that right? 9 could go with 2 and 6 with 1. That's 7, 11. Or 9 could go with 1 and 6 with 2. That's 8, 10. Yeah, 8, 10 or 7, 11. 7, 11 would be nice because it would do a lot of work here. Ooh, hold on. If this is 7, 11, that can't be the Schrodinger. So this is the Schrodinger, this is the Schrodinger, and this is the Schrodinger. And this can't be 7 or 11, so it would have to be 15. But I think that works. Oh, I think that works. This couldn't be... oh no, 15's already taken. 15's already taken. 15's already taken by 6, 9. I love that. That's great. So, okay. I don't think that lets me put any digits here, actually. Let me think about that for a second. But there's two possible ways around this can go, right? It's either 6, 10, or sorry, 8, 10 or 7, 11. If it's 7, 11, 11's taken, so that's not Schrodinger. That is. What is this cell? It can't be 7, 0, because that would be 7, and 7's taken. It can't be 7, 4, because that's 11, and 11 is taken. And it can't be 7, 8, because 15 is taken. So this is 8, 10 in the bottom left. The Schrodinger cells are 8, 10, 3, and 15. But that doesn't resolve this. So how do I use that information? 8 seems like the one that's useful because there are some things here that could be 8, like these could be a 0, 8. Oh, and now that this is 15, I can do the same logic here, where if this is Schrodinger, these are all Schrodinger. I need to have 11, 7, and 7, 8, which is 15, which can't work. So in fact, this is not a Schrodinger cell. I don't think I can say that about these though, because that would do something like this, and that would do something like this. So this is just a bare 7. Okay. So one of these is a Schrodinger cell, and it's not 8, 4, because that's 12, and it's not 8, 0, because that's 8, which is down here. So there's a Schrodinger 4 up here. So one of these is just a plain 8, and one of these is a 0, 4 pair. Does that help me down here? Now the problem is 7 could go with 0 or 4, and 5 can go with literally anything. And this doesn't violate with any version of this. This doesn't violate with any version of this. This doesn't violate any version of this. This doesn't violate any version of this. A and B are 1 and 2, so these don't get violated either. One of these is 8, so one of these is going to be not 8. Hold on. Let's think. Maybe I can place digits here now that I know what they are. Can I? Probably not, because yeah, it's either B is 2 and D is 6, or it's B is 1 and D is 9. But I have no way of figuring out which way it is. Right? How do I figure out which way? How am I ever going to figure out which way that is? Probably I'm gonna have to figure out which of these is 8, and that's gonna tell me which way that goes. Okay. So how do I figure out which way is 8? I have no idea. If this is the Schrodinger cell, it can't be with 8, so it's a 0 or 4. That could be with anything. So if this is Schrodinger, that's 8. If this is Schrodinger, this is Schrodinger, this is Schrodinger, but that could be either one. Well, what does Schrodinger here mean? Schrodinger means 0, 4, right? So this becomes 8. 8, 8, that's 5, that's fine. 8, 8. Hold on. Did I do that wrong? I think that's broken. Hold on. if this is Schrodinger, no. If this is Schrodinger, sorry, I'm having trouble. If this is Schrodinger, it's 5, 8. Which means this is Schrodinger, which means it's 0, 8. Which means this is Schrodinger, but this is already 4, so it'd be 7, 0. So if this is Schrodinger, it's 7, 0. But this 0, 4 means this is 8, this is 5. I think I just did I think that's okay. I think I get 8s there. Not there. Oh, hold on. No. Much simpler. Much simpler. If this is Schrodinger, the not Schrodinger here is an 8. This is much nicer and much simpler. If this is a Schrodinger cell, it has an 8 in it. But then this is not a Schrodinger cell, which has an 8 in it. So this is not the Schrodinger cell, which means I get the Schrodinger cell of this orientation. And that's going to resolve everything. So that's a bare 7. That's 0, 4. That's 8. Just for completion, we will color that green. This is now an 8, which means that's an 8 from the 7, 4. That's a bare 5, 0, 8. So that's 4, that's 0, that's 4, that's 0. That's 0, and the Schrodinger cell makes that 8, 0. Okay, and now I know that that's 8. So this is an 8. So AC is actually 10, which is 1, 9. Which means B is 2, A is 1, A is 1, B is 2, this is 2, 6, which means those are 9 and these are 6. And that is the puzzle. Wow, that's really cool. I'm surprised more people have not solved it. It didn't seem that hard, but I think Pedaling Pianist and I tend to be on the same wavelength a lot of time with puzzles. So things that, I don't know, that happen to mesh with our brains are weird and other people don't get as easily, I guess. Anyway, great puzzle. Thanks for watching. Thanks for setting. And again, go rate this puzzle on LMD if you have not already. All right, thanks. Bye.